Okay, so this lesson is section 6.2 out of our geometry textbook, and it's about using proportions to solve geometry problems. So we have a few properties that deals with proportionality. One of them is called the reciprocal property. If we have two ratios that are congruent or they're equal, the reciprocals are also equal. So we know that a reciprocal is when we take a fraction and we invert the numerator and the denominator. So for example, if the proportion A over B equals C over D, then their ratios are also equal. B over A equals D over C. The next property that we have with equal proportions is if we interchange the means, we can form another true proportion. So B and C right there are our means of this ratio of this proportion. And so if I interchange B and C and put C in B's place and B in C's place, then we also form another true proportion. And the last property of proportionality is if we add the denominator to the numerator on both sides, then we also form another true proportion. So in the first ratio, B is in the denominator. If they add the B to the numerator, and same thing with D, D is the denominator. If I add D to the numerator, then we have another true proportion. So here's some examples of using some of our proportionality statements. First, they just want us to write four true proportions from the information. They give us two triangles and their measures, and they give us a proportion that says the length of MN to the length of RS equals the length of NP to the length of ST. So the first proportion we can get would be from when we just fill in those measures of those lengths. So the length of segment MN is 8 units. The length of segment RS is 10 units. The length of NP is 4 units. And the length of ST is X units. So there's our first proportion, and that just comes from filling in our lengths that they give us in this statement right there. Let me draw a better box. So I just filled in the measures from the pictures. So the second one, we can get another true proportion if we use the reciprocals. So the reciprocal of 8 over 10 is 10 over 8. The reciprocal of 4 over x is x over 4. So there's another true proportion. The third one comes if we interchange the means. So I'm going to use the original proportion that I used from where I filled in the measures of the segments. So if I interchange the means are the 10 and the 4. So I can say 8 over 4 equals 10 over x. So I just swapped the places with the means, and the means with 10 and 4. So I just replaced those with the other one in their location of the proportion. And the last one, if we add the denominator to each numerator, then we also have another true proportion. So if I take the original, the one that's highlighted in yellow, the denominator is 10 on the first one, so I can say 8 plus 10 over 10 equals, the denominator is x on the other one, so it's 4 plus x over x. So there's my four true proportions. All right. So we're going to use some proportions to help us to find missing lengths in triangles or other quadrilaterals or any other polygons. So this one, they give me the proportion, the length of BD to DA equals the length of BE over EC. They want us to find the measure of BA and BD. So first of all, I'm going to fill in the measures from the pictures of the triangles to my proportion right here they give me. So first of all, the length of BD is not known from the figure, but I do know the length of BA and DA. The length of BA, which is that whole segment of that side of the large triangle, is X, and the length of this little portion of it down here is DA, is 3. And so from the segment addition postulate, I can say the length of BD is going to be the length of X minus 3. So that's what I'm going to write in my proportion for BD. X minus 3 over the length of DA, which is 3, equals the length of BE, which is 18, over the length of, EC, which is 6. Then I cross multiply to solve my proportion. 6 times x minus 3, and we'll have to distribute that, equals 3 times 18 is 54. So that is 6x minus 18 when I distribute equals 54. I'm going to add 18 to both sides. And it says 6x equals 72. And I divide by 6, and x equals 12. But they want me to find the length of segment BA and the segment BD. Well, BA is the length of x, so that is what 12 equals. So there's that one. And BD is going to be x minus 3. So BD is going to be 12 minus 3, which is going to be 9 units. So I found the length of BA and the length of BD. All right, let's do one more example. Again, they gave me the proportion that we're supposed to use to find the missing sides. And they said the length of SV over VT equals the length of SU over the length of UR. So we're going to fill in the missing or the sides that they indicate. So SV's length is 8 units over VT. I don't know what VT is, but I know that the entire ST is X and the SV part is 8. So it must be X minus 8 units. So that goes in my proportion for VT. X minus 8. SU's length is 12, and UR's length is 28 units. So cross multiply, I get 12 times the quantity X minus 8 equals 8 times 28 is 224. And then I distribute my 12 here, and I get 12X minus 96 equals 224. Then I add my 96. And I get 12x equals 320. And I divide that by 12. And I'm getting that the length of x is approximately 26.7. It's 26 and 2/3 to be exact. I'm going to round it 27 or 26.7 units. I don't know the units. And I use this symbol for approximately because it is not exactly 26.7. It's exactly 26 and 2/3. So we do not ever want to say something equals something when we approximate. So x is approximately 26.7 units. It wanted us to find the length of segment ST and the length of segment VT. Well, ST actually is the whole entire length of that long side of that triangle. So that's what x is by itself. So that is ST. I should use approximately. And the last one, they want us to find VT. So VT is going to be approximately x minus 8. So 26.7 minus 8, which is going to be approximately 18.7 units. And that is the end of section 6.2.